So then you should probably know what the database and frequent performance trouble is. In so many time, I would come to a customer and they would have their website or app slow or down, and I would tell them, what's the problem? And they say, oh, that's a database. I would say, why do you think so? And they tell me, well, because it's always a database. So why databases are really painful to scale and deal with performance? I think there's those few things. One is generally you don't have a very linear scalability, right? You put more traffic on database, it doesn't happen to scale linearly. As your data grows, the queries also typically don't have a linear scalability, right? The other thing is database are typically very complicated pieces of technology. And also, developers often don't quite understand it very well. Right? Well, you have this kind of query, but why that would be slow or fast, how optimizer works. For many developers, that all is really a mystery. So now, if you look at performance work, we typically do a database, that's would be one of those things. Troubleshooting, right, then the problem happens, and you need to fix them, make fast what was slow before. Often you also have to do capacity planning. That means to understand how much traffic, how much load the database can handle. And also, increasingly now we have to do something to cost and efficiency optimizations, which is especially relevant in the cloud, right? You can really be, if you're wasting money, you can sort of scale your instance down and start saving them today. And also change management, right? And by change management, I mean if you go ahead and you upgrade to the next database version, chances are something will be going faster, something will be slower, and you need to work to figure it out. Now, when you look at the databases, you can pretty much look at from a 2 points of view. One is black box, and that's how application developer look at that. And then there's also white box, where we understand a lot more about the internals. That is how DBA, SRE, other ops people often have to look at that. Now, if you look from a database or a developer point of view who looks at a database as a black box, it looks very simple, right? I have my queries, I throw a database, and it responds to me, right? Very simple. And developers often think about, oh my gosh, why those stupid nasty DBAs can make this database just work, right? Why? It cannot just handle the queries I throw at it, right? Now, what is interesting though is with the cloud and a lot of phrase of database as a service offering. Often, even if you're in operations, that is as much of visibility and that's the mode of operation you would have, right? Because you may not have complete insights at the internals what happens with the database as a query service. So if you think about from developer standpoint, it's very simple to look at the criteria. What makes a good database, well-behaving database, well-performing database, right? You want that to be up. Of course, when you send your queries to database, you care about response time. You want them to respond fast, and you obviously want to have a correct queries, right? Correct responses or data being updated and preserved correctly. And also you want, obviously, that not to cost you a lot, right, to be efficient. Again, especially in a cloud system where sometimes they can sort of, let's say, automatically scale for you, right, but if you are doing stupid things, it's going to cost you stupid money. Now, from an ops point of view, when you often have to look at a lot of more internals, right? You hear about the load of the systems, resource utilizations, if there's, let's say, some operating systems or hardware problems happen, right? We have to deal with that, as well as scaling and capacity planning to handle the needs of applications. So that is the overview, right? A very brief one. Now, if you what you'll spend more time here is looking at the methodologies for troubleshooting and analysis. And let's see how you find many people and kind of what I would call a typical approach. is troubleshooting by random Googling. Right? I mean, you go ahead and you have some problems you understand, you enter that in Google, and hopefully you'll get response on the front page, right? Now, the problem with such typical approach, it's pretty much hard to assure outcome, right? Because as wonderful and smart Google is, its search engine ranking doesn't really have anything to do with how relevant the answer is to your particular problem, right? It's also hard to train people, right? Because that is way too general, and that's also hard to automate or even create something as a checklist, right? To go through. And that is why there are a number of methodologies exist to troubleshoot the databases. And I will very briefly cover a few of them. None of them are really database related, but because we deal so much with database component, I will talk about how they apply to the databases. The first one is the use method by Brandon Gregg. Anybody heard about this one? Oh, well, fantastic. Many hands. And what the use method is, or what it was developed by Brandon for, is to pretty much troubleshoot server performance, first and foremost. And the idea is how can we resolve 80% of the problem with 5% of the effort, right? So it doesn't claim, hey, by following those simple stacks, simple checklists, we can solve everything, but we can solve a lot of them in a relatively simple way. The great thing about this method is also that there are a lot of the great checklists are available, which can tell, hey, if I want to follow this method for this environment, that is exactly what I can do. Now, if you describe that method in one sentence, it would be for every resource, check utilization, saturation, and error. Now, there are a few definitions which this method would use. First is we talk about resource. And a resource would be all server physical components like CPUs, disks, memory, and so on and so forth, right? These are kind of your basic foundational resources which have certain capacity, right? And you know, if you try to make your disk to do more IOPS than it's designed to handle, well, it just wouldn't do it. Now, utilization is a measure that tells us what the average time resource was busy servicing work, right? It's kind of pretty simple, busy or not. But now, even if but then another good measure for resource usage is the saturation, which tells to what degree a resource has an extra work to do, which it can serve, which is often due. Right, so for example, for disk area, you may be looking at the disk utilization, but also queue depth, right? A number of those requests which are being waiting in the queue, that would be a measure of saturation. Now, another thing which is important to look at is current of error events, right? Because error events can cause both resource slow down, right, and perform poorly, as well as in some cases when you oversubscribe the source, right, you start getting error. So for example, you think about the network, right? First you get network oversaturated, become slow, but sooner or later you simply can't, let's say, establish connection, right? Because of timeouts, you just get an error. So here are resources which we often have to deal with. It's CPUs, right, which would be your CPU ports and hardware threads, memory, right, memory capacity, and is very important here. The network interfaces, storage devices. Again, for storage devices, you would look both at I/O usage as well as the space usage, because obviously if the disk runs full, it tends to cause problems. Your virus controllers that store the network cards and virus interconnect, right? Where interconnects between different devices can become overloaded and cause performance problems. Now, this all talks about applying the use method to the hardware, But how does that work with the software? Can we really use that? Right? And the idea is, yes, we can use it in software as well, and the same basic principles would apply, because if your hardware is oversaturated, right, by demands put in by the software, you'll have performance problems. But in software, there are some other components which apply. So, for example, multi-clones, right? In many cases, you may have hardware not being overly used overly high, but you have Unix contention, right? And you can think about that as a resource, the utilization saturation. Another good example is file descriptors, right? I mean, if software runs out of the file descriptors, then it probably will fail. Or in case of databases such as MySQL, one of the common problems in capacity planning is not having enough max connection set, right? You run out of max connections, your application will start failing, right? Not because of any hardware resource usage, but because of the software, the resource gets all completely used up. Now, the use method benefits, it has a proven track record, it has also pretty broad applicability, and there are a lot of detailed checklists available. Now, the drawbacks here would be what it really requires you to have a good understanding of the system architecture, right? What different problems are and how we respond to resource usage. It also really requires you access to the low-level resource monitoring. So, for example, as I mentioned, if you're using database as a service software, right, you may not have as much details about how that all maps to different resources and what's happening out there, right? And in general, it's kind of really, I assume you have a lot of that wide box understanding and insight. So here comes the red method. Right, and that is, you can think about that as another look at essentially the same resources, but applicable to more of a white box system. The red method focused a lot of microservices, right? When you have this concept, hey, we are not teaching our system components as pets. As cattle, they kind of very transitional, they can go ups and downs, right? And mapping to resources with microservices in this container can be hard because it's kind of fluid, right? Your container may be running here and then in another location. Now, to be honest, even if you treat database as pets, they kind of tend to be pretty important, not pets, but cattle tends to be pretty important cattle, right? Because of that kind of state and kind of it's really a relationship to the data. So keeping that in mind too. So red method says this: for each service check, right? Remember, in this case it's a service, not a resource. We can check what those items are within SLO, and that stands for service level objective, which is rates, error rate, right, and duration, right? And duration pretty much talks about the response time distribution here. So that means that, hey, if I have, let's say, sort of function on a server level, I should say, hey, this resource should be able to handle up to 1,000 requests a second. There should not be no more than 1 error per million, and right, duration, I should get 99% is responded in 10 milliseconds, right? Something like that. Then apply that to the databases. Of course, we can look at that from different levels. It's a good idea to apply that as on a service level. For example, you may have some sort of load balance in front of the database, but you also want to look at that often on the individual database servers, because often you would have only one of them malfunction because it's overloaded, or maybe because database has some stupid execution plans on that particular board because statistics are off. It also can be applied to a component and resources inside the database service, right? Like, for example, you can think about the disks or other components. And also, I think what is wonderful, it can be applied to individual types of queries you're from, right? Because different queries, they tend to have a different goals. Your search query may need to respond in 100 milliseconds, while your kind of simple lookup query may need to respond in 1 millisecond, right? Or that. Now, in terms of benefits, I think what this method really covers, you can see pretty much the same things we talked about, right? What developer care, then they work with databases, right? So that I think is wonderful. And it also doesn't require as deep understanding of the system's architecture as a use method does. And it also does not require as much access to low-level information, right? You can really see what kind of servers are giving you trouble pretty by observing that from the outside, if you do, right? Now, if you have a drawbacks out there, it doesn't have as much detailed checks lists for that, or well-developed kind of really detailed tool sets developed for that yet. And also, it focuses more on finding what is having a problem and why, right? So I can identify that as this microservice, for example, is malfunctioning because it's not really working well, right? It's too slow, it's throwing too many errors, and then we can get that microservice developer, right, or other responsible person, or irresponsible, I guess in this case, it's malfunctioning, and go and fix it. Okay. Now the third one, and the last one I'm going to cover, is called the 4 golden signals. And that comes from a very well known by now is chapter of a monitoring distribution systems for SRE, Site Reliability Engineering book, which is based on lessons in the Google. And it is not just a monitoring focused. It also can be used for other things such as alerting and the trend analysis, right? But it, I think, is very applicable in this context as well. So what are those 4 golden signals? First one is latency, right? We are looking at the latency of requests. And in this case, we want to look at the latency distribution, not just averages. Averages in general is a bad measure, right, when it comes to performance management. We want also to make sure when we look at the average, at the latency differently for successful requests and errors. Because in many cases, your errors can be thrown very quickly, right? Let's say if I'm trying to, to connect to MySQL, to run some expensive query and I fail, I will get an error, but that's really very quick, right? We also want to look at the traffic, right? And this is similar to a measure of rate, right, from a rate. How much requests a system is getting, right? How much demand is generated in the system? Because obviously, if there is, let's say, too much traffic, too much demand, hey, here we got it, why the system is not functioning. We look at the errors, right? And for errors, there are kind of two kinds of errors, right, for systems in general. There are errors which are based on the error codes, and these are typically easy. And there are also errors which are when a content is wrong, which is a lot harder, right? So for example, especially for database, if I run select query and because of the bug in a database, I get the wrong content, it's very hard to find out, right? Typically it gets user to complain, right, or some automatic test may be failing, but it's hard to integrate that with performance management practices. Thankfully, it doesn't happen that often. And the saturation, which tells, in this case, about more highly level saturation, is how full the system is to capacity, right? So if you have done capacity planning and you know, for example, oh, my system can handle, let's say 10,000 queries a second, right? And you are at 5 right now, right? And you can talk about certain use of capacity. So for databases, what you can do here, for latency, look at the response time distribution, and especially good by query digest, right? And just to clarify, digest is essentially type of query with all the kind of parameters picked out from that. Traffic, that could be number of queries, and again, you can look at specific kind or by the digest. Sure, that's a very good measure for MySQL. Error codes, for errors, that's going to be error codes, but also wrong query responses, which again is particularly hard. I would point out for MySQL, a lot of that's kind of wrong responses, they come to inappropriate user replication, right? MySQL replication is asynchronous, and if you don't have your good monitoring in place, you may have a slave log in, let's say, half an hour. You go to it and you get a very old stale data. If your application is not keeping an account for that, that is the most typical case when developer thinks he's getting the wrong responses, right? Just not keeping that asynchronous replication account. And saturation. We can look in this case at the basic resource usage, CPU, disk, wherever, but also things like connections and the disk space, right, is also very important, because often problems happen when you run out of the disk space. Now, from a golden signals, that is a methodology which seems to be working well for Google and some others now. And I think there's a good resource book available about that, and really how that fits in the general concept. Now, drawbacks, again, that is not just monitoring, and because of that, there is no very specific checklist which are available. Okay. So now, from a takeaways for me, if you look at all those methods, they're all relatively recent, right? I think the first publication about the use method, that was probably about for 5 years ago, right? I think other two came somewhere between the last 2 or 3 years, and I'm very glad that we have a lot of methods being developed for this in our industry now. Right, and also what is interesting in this case, if you really compare those methods, there is a significant overlap in them, right? They're all looking at those relatively same things, just from slightly different angles. Now, for us at Percona, we are working on figuring out how to get those methods to be integrated with open source tool for monitoring. We are developing, which is called Percona Monitoring in management, and right now that's mostly ideas. We don't really have too much the insights, too much of a specific method implementation out there. And the final thing I should say, if you guys are interested in a open source databases, we are running the conference in April, so we would very welcome you to come and attend that. And that's it. Thank you. I would be happy to take some questions outside, and also we have a table here, right? So please come by and talk to us about it.